Let's start. So today we will be discussing on binary search, and as you can see, the agenda is that we will be focusing on interview questions which have been asked at Google. And these are curated list of questions that we have got from personal interviews of people who have attended Google interviews from our institute and also from other websites and places. So without much delay, let's right away jump into binary search. So I will just explain in brief how the flow of this session is going to be. And before that, I can get a thumbs up on if you guys are able to see my screen and my voice is audible. Can someone confirm? Awesome. Okay. Cool. So we'll be starting from basics and we will slowly go to easy problems, medium problems, and hard problems. Medium and hard problems are generally medium problems are asked at Google interviews. And occasionally you may also encounter hard problems, but for that you get some extra time. Okay. So you will be expected to do one hard problem in 45 minutes to 1 hour and two medium problems in 45 minutes to 1 hour. In general, that's the pattern at any Mang Fang companies, right? So having said that, let's start. So firstly, what is searching? So given a list of numbers and you need to check if X is present or not. This is a classic statement for searching. And this is what searching is, that given a sequence, I will give you a number and you need to tell me yes or no if that number is present in the sequence or not. Another type in which I can paraphrase this question is, given a list of numbers, tell me the first and last occurrence of X. For example, 5 occurs multiple times in the sequence, then you need to tell me the first and last occurrence when 5 came in that sequence. That's another type of searching problem. Another variety of searching problem can be how many times X is present in the list. So all of these come under searching. Okay. And if you see, any problem breaks down into either sorting, searching, generally. Most of the problems that you will be solving will be either in some way you will be searching something or sorting something. So that's pretty much when you go to the basics of any problem. So what is brute force searching? We are all aware about it without much delay. It's just given a sequence, you will iterate through every element in the sequence and you will perform some operation with respect to the number that you have. So for example, if I ask you if X is present or not, then you will go through each element in the sequence and check if that number is equal to X. If it is equal to X, then you have found that number, you return yes, otherwise no. If the question is that find number of times X has occurred, then every time X comes, you have a counter, you do it plus plus, and at the end, you return that this many times that number has occurred in the sequence. Okay, so that was all the context which I think is needed for anybody new who has no idea about searching or anything. And now let's come to binary search. So binary search is an algorithm to search an element in a key point sorted array. Okay, so we will start with this, and towards the end of session, you will see that we also go to unsorted arrays and perform binary search on it. But because we are just starting, so let's say that binary search is an algorithm to search for an element in a sorted array. So let's see what it is. So binary search performs the search in order of log n time, where n is the total number of elements in the array. To give you an idea what log n is, I will not go into detail of time complexity, derivation and all, because that is out of the scope of what we are discussing today. But to give you an idea, that if there is 1 million numbers, sorted sequence of 1 million numbers, then in only 20 lookups, you will be able to detect if a number is present or not in that sequence. So this is the scale that we are talking about. In 1 million, in only 20 steps, you will be able to know if a number is present in a sequence or not. How? Obvious next question is how. Sounds like magic. So that's what we are going to firstly study. And then we will raise the bar to one of the most difficult questions that can be asked in binary search. Okay. So if you have any questions, feel free to unmute and ask that question or drop in a message in chat. So does this mean we can search for an element in a list without even looking at all elements in the list? Yes, that's what it means, right? If there are 1 million numbers which are sorted, and in 20 steps you are able to find whether a number is there or not in the sequence, then you are basically not even looking at all the numbers. So it sounds a bit strange that how come without even looking at all the numbers, you can tell whether a number is present or not. And the simple answer for that is that there is a pattern in the sequence, which is that they are sorted. I will paraphrase that question, asking you a return question that when you search for a word in a dictionary, do you go over all the words in a dictionary? Obviously not. You'll probably take an entire day if you start going over each and every word to just search a word in a dictionary. But you have some algorithm in your head. You open middle of the dictionary, you see, oh, this is Q, and you have to look for D. So then you go to the first half, and then you see what's there, and so on and so forth. You keep proceeding, right? So we will study that, what that something is. But we inherently are doing binary search when we are looking up in a dictionary. We all have done this as kids. Maybe we were a little bit inefficient, but we were not that dumb that we would go over each and every word in a dictionary. Rather, I would be very surprised if someone here has done that. Yeah. So now let's see what a trivial binary search is. And before we start that, any questions so far? I hope I'm clear. So for those who have joined a bit late, we have just started. The session is on binary search, and now we are studying what is binary search. So binary search is that you go to middle of a sequence, you check what number is in the middle of the sequence, and you see whether the number that is at the middle is greater than the number you're looking for. If it is greater than the number you're looking for, then your answer is in the first half, right? Lower half. If the number is less than, if the middle number is less than what you're looking for, then you will go into the higher half. And if it is equal, then congrats, you have got your answer, right? So these are the steps, and it is very easy. So I won't go into basic level explanation, but it should be very clear, right? So what are you doing? At each step, you're going to middle of a sequence. You are asking one question, which is it greater or smaller? And based on that one question, you are able to reduce the problem space to half, right? You have an entire sequence, you go to the middle, you ask a question. If it is greater, then lower half, or greater or higher, depending on that, either you go to lower half or higher half. So you have basically reduced the problem statement into half. Imagine you are looking up for a word dog in a dictionary, and you open up the dictionary and the word that you see is queen, which means that you need to look in the first half, not at the last half, correct? Then you come in between the dictionary and you see that the word is fish. Now you know that again the word will be in the before fish, which means the first half. So every time you will see that the sequence will be reduced into half, 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 half. And that's why there are too few steps that we will take to determine whether a number is there in a sorted list or not. And that's the beauty of binary search. Any questions so far? Am I audible, and is everybody able to get it? Yes, no? I hope I'm audible.
Yes, all good.
All good. Okay then. Okay, so this is the code of binary search. This session, intentionally, we will be doing some hands-on coding. Okay, and basically this will be a little bit hands-on. Okay, so this is your trivial binary search algorithm. This is a recursive algorithm. You can see here, if the middle is equal to target, then you return whatever the index is. So basically binary search is returning the index at which the target is present. So binary search takes into input is the sequence, which is vector int, then low and high. Low and high means basically think that this will be 0 to n, right? 0, lowest index possible to highest index possible, which will be n minus 1 actually, and then target. So from 0 to n minus 1, we will go to the mid. Okay, how we get the mid? Low plus high by 2, right? And we get to the mid, and we see if the number is equal to mid. If it is equal, luckily you have the answer. If not, If the number at the middle is greater than what you are looking for, then you will go in the lower half, low to mid minus 1, right? Because at mid, the number is not there. So you go to low to mid minus 1. Your problem space has reduced now. From low to high, it has become low to mid minus 1. And if it is else, which means if the mid number is smaller than the target, then you go in the last half, which is mid plus 1 to high, which is the later half. Okay. As written in English, very similar, the code is, and it's a 5-line code that works. Okay, and how that works, you will know, because we are actually going to code this out and submit it. Okay, so this is what I told. So this is the recursion. So the recursion breaks at if low is greater than high, we return -1. Middle is equal to low plus high by 2. If the sequence is, if the middle number is greater than the target, then we go to the lower half, otherwise the higher half. And if it is equal, we return mid. So I have not written the equal condition because only 3 things can be possible, right? Either the middle number is greater, smaller, or equal. So implicitly, this will be only returned for equal case. So I will just run this code and I will submit this code. Okay, accepted. And you can see the description is very simple. What I have said, given an array of integers, nums, which is sorted in ascending order, like I have told, and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. So -1 we are returning if we don't find a number. Okay. So far, so good. Now I will. Is my screen sharing paused? Are you guys able to see my screen?
I'm not able to. We are only seeing the binary search problem written in the pink color.
Oh, okay, okay. 1 second. Sorry. Thanks for pointing it out. Stop. That's because I haven't shared my entire screen. Let me share my entire screen. I hope now you are able to see it, right?
Yeah.
Yes. So thanks for pointing that out. So like we said, so this is the code that we discussed, right? That if low is greater than high, then we no, if low becomes greater than high, then this means that the recursion has to stop, right? Low cannot be, your lower index should not be higher than your higher index. So if low is greater than high, then you return -1. Otherwise, you can ignore this for the moment. Okay, I will come why this is needed. This is called base condition. So we find middle, low plus high by 2, we get the mid. If mid is greater than target, then we look in the lower half. Exactly what I told here, right? If mid is greater, then look in the lower half. You were able to see my screen when I switched between slide and a browser, correct? Can somebody confirm? Just to make sure.
Yeah.
Awesome. And if the middle number is less than the target that you're looking for, then we will go to the higher half of the array. If it is equal, then we will return. Because I'm returning in the first 2 conditions, it is implicit that this will be returned only if nums mid is equal to target. And now why do I need base condition? Let's answer that question. What if the number is not there in the array? Let's take this example. Okay. 1, 2, 3, 4, 6. And you're searching for 5. So how will binary search start? Binary search will start, I will call binary search the array, right? In this case, we'll pass the lower sequence as 0. What is the size of the array? 1, 2, 3, 4, 5. 5 numbers are there, but the longest, because this is 0 index, so the highest index can be 4, and the target that we are searching for is 5. So firstly, we will call this. So this will be the first statement, as you can see. From the main, this will be called array 0, 4, 5. Okay. When we will call 0, 4, 5, then mid will be evaluated 0 plus 4 by 2. What will mid come? Mid will come 0 plus 4 by 2, which is 2. What is the number at 2th index? 2th index, remember, this is 0 index. So 2th index will be 3. So 3 is greater than 5 or less than 5? 3 is less than 5. So we will binary search mid plus 1 to high. So next recursion will be binary search array. Mid was 2. So mid plus 1 is 3, right? 2. High. High is again still 4. And you're still searching for 5. So now the next call will be 3, 4, 5. Now what will happen? This means that you are searching for a number 5 in an array between index 3 and 4. So we'll again follow the same routine. We will compute the mid again. 3 plus 4 by 2. Mid comes out to be 3 again, right? Middle is 3. So what number is that third index? Remember, this is 0 index. So the third index is 4. So now 4 is greater than 5 or less than 5? 4 is still less than 5. So you again go to mid plus 1, right? Too high. So binary search. This time the mid came out as 3 plus 4 by 2 is what? 3. I hope this is clear because this is integer division. It will not be 3.5. It will be 3. So still it is 3, but we are doing mid plus 1. So 3 plus 1 is 4. High is still 4 and 5. So now this will be the last call that we will make. Now you will see why base condition is necessary. When we will make 4, 4, 5 call, then again we will evaluate mid. Mid comes out to be again 4. Mid is 4. So we look the number at the fourth index. Now the number at the fourth index is the last number, which is 6. 6 is greater than 5 or less than 5. Now this time 6 is greater than 5. So now we will launch nums low mid minus 1 target. So right now low is 4, high is 4, mid is also 4. So now what will I call binary search? Can anybody answer? Array low is 4. Mid was 4. So what will be mid minus 1? 3 and 5. So now I will call this. And when this condition will come here, if you don't have your base condition, then you don't ever end your recursion. This is invalid, right? Now you should stop searching. You did not find 5 in the sequence because it is not there. So you need this base condition. Low greater than high, return minus 1. I will just submit this solution and no surprises. Let me comment this. And this is submitted. Any questions on this? This is the trivial for those who have joined a bit late. We just studied what binary search is, and I just coded and showed you how to submit binary search solution in 5 lines of code. And this is the problem statement. Problem statement is the same. To those who have joined late, given an array of integers, which is sorted in ascending order, and given an integer target, write a function to search target in nums array. If target exists, then return the index, otherwise return minus 1. Write an algorithm in O log n time complexity. This is a trivial binary search question, and this is the solution. Any questions so far? If there is any questions, I will clarify. Now the level will keep increasing. As promised, we will go to the Google level of question in this session. Any questions? Any questions? Nope. Yes. Any questions? Any doubts? Anybody wants me to repeat this? I am happy to repeat it. Okay. Going once, going twice. Okay, moving ahead. So now let's come to the next question. And as promised, this is going to get harder and harder. So now you need to use, no, this is my favorite part. So you need to use binary search to find square root of a number. I'll give 30 seconds for you guys to think. And if somebody can tell me approach, I'll be very happy. So let's play a number game. I'll not give you the answer very easily. Let's play a number game. Okay. And then after this number game, probably you guys will be able to find the answer, but I need some interaction. The audience, it is necessary to know recursion in order to do binary search. Not really necessary to know recursion, but why I'm using recursion is that in an interview, if you are writing binary search code, and if you are taking 15-20 minutes to just write binary search code, then that's a red flag, right? If you start writing iterative code, you'll take some time. I always advise DFS, binary search or anything, it should always be written recursively, because as you saw, it is 5 lines of code, performant, equally competent, and it saves you time. So just to give you an idea about what time scarcity you will run in Fang interviews is that you will have 45 minutes. You'll have actually 1 hour. 15 minutes will go in your introduction and the guy's introduction. And then he will ask you 2 questions in 45 minutes. So 22.5 minutes each. 2.5 minutes will go in explaining the problem and you understanding the question. This is considering that you are sharp enough to get the question easily, right? Otherwise, it can go up to 5 to 10 minutes. If from 22.5 minutes, you take away 10 minutes, you have 12.5 minutes to implement the solution. Do you think you can write an iterative code with a while loop and lots of blah, blah, blahs there, around 10 to 12 lines of code? So each line of code you're writing is actually a clock ticking against your candidature. So always prefer recursive codes. It is good in production, it is readable, and it is much more maintainable, right? So just for an idea, you can literally read this code like if low is greater than high, return -1, mid is the mid of the sequence. If the number is greater than target, then search the lower half. If the number is less than target, search in the higher half. If it is equal, return. Right? This is highly readable code, best quality code that you can write for binary search. So I will recommend to use recursive code, not iterative. I hope that answers. Okay, so let's play a number game. I'll need your interaction. So feel free to unmute yourself and speak. Okay, so think of a number, don't say, think of a number from 1 to 100. In how many trials? So let's say some person here, let me start picking. Let's say Ankita. Ankita guessed a number from 1 to 100, which is, let's say, something. I don't know what she has guessed. Now I will try to guess what she has guessed in as less trials as possible. I'll make some guesses. Of course, my first guess won't be correct, my second guess, but my aim will be to make least number of guesses to get to the answer. Basically, I'm trying to predict what she has guessed by making some guesses. And each time I guess, she will have to reply with greater, smaller, or equal. If my guess is greater, you have to tell greater. If my guess is smaller, you will tell smaller. If it is equal, you will tell, okay, you have got it. So can anybody volunteer? Can anybody take a guess from 1 to 100? And then I will try to guess. Or if somebody wants to guess what I have guessed. 56. You don't need to say. Let's say you thought of 56. Now it becomes easy for me, right? Is it 56? Don't tell me your choice. You will have to unmute yourself. Otherwise, I will have to play it like a schizophrenic person.
So I just guessed,
yeah,
guessed the number.
Okay, awesome. So I will start now. So is it 50? 50. Now you need to tell greater, smaller, equal. 50.
So 50 is basically smaller than 56.
Okay, you don't tell 56. You choose a different number altogether.
Okay. So I choose the.
Don't tell me. You choose something. Okay. You have chosen something.
Yeah, I've
now,
chosen something.
Same question. 50. Greater, smaller, equal.
It's a greater.
Okay. 50 is greater. So 25.
It's a smaller.
25 is smaller than the number that you have guessed.
Right.
So I'll go somewhere in between, which is 37.
Sorry?
37.
37 is smaller.
37 is smaller. So I have to go between 37 to 50. So I will make a guess, which is 43.
43 is greater.
43 is greater. So my search window is now 37 to 43. So I'll make a guess, which is 40. 40
is greater.
40 is greater. So the search window is 37 to 40. So my next guess is going to be, let's say 39.
39 is the right answer.
Awesome. So if you have counted, I started with 50, then 25, then 37, then 40, and then 39. I took 5 trials to guess a number from 1 to 100.
6 trial, 43 as well.
हाँ, 43 पे तो मैंने guess कर. Yes. अच्छा, 43 पे. Okay, 6 try. Let's 6 try. ठीक है. So 2 power 6 is 64. 2 power 7 is 128. So worst case in 7 trials, I could have guessed. So I guessed it in 6. Not bad. Because every time I will be dividing the sequence into half. So it comes out as 2 power x equal to 100. So maximum I could have taken 7 trials. I solved it in 6. So it's not that bad. Okay, so now that you have played this number game on a number line, so this I'm trying to shift the paradigm of your thinking that forget about sequence. The number line itself is a sorted sequence of numbers. Okay, so now if I ask you a question that you need to find the square root of a number and you need to tell me the lowest integer possible. So square root of 5 will be 2, not 2.23 something, which is the actual answer. But you have to tell me 2 integer square root. Okay, so now how you will solve this problem? Okay, so now I will use the same technique. Let's say you want square root of 49. Okay, so the answer will be between 1 to 49. The square root of 49 will be in between 1 to 49. Correct or not? Correct.
Right.
Now 1 to 49 is sorted. So I will start with midpoint of 1 to 49. 1 to 49 ka midpoint is 24. So 24 times 24 is approximately, not approximately, exactly, I think 576. 24 times 24 is 576. So 576 is greater than 49, no doubt. So now I will go in higher half, like I will search in 24 to 49, or I'll search between 1 to 24.
1 and 24.
1 to 24. So 1 to 24, again, I will bisect it right in the middle and I'll land at 12. And 12 times 12 is 144. 144 is still greater than 49. So I will go look between 1 to 12, right? Now 1 to 12, I will get 6 bisected in between. 6 times 6 is 36. And 36 turns out to be smaller than 49. So I need to go higher than 6, but less than 12, right? Less than 12, but higher than 6. So it is between 6 to 12. Now 6 to 12, what is the midpoint of 6 to 12? 9. So 9 times 9 is 81, again greater. So the answer is between 6 to 9. 6 to 9, the midpoint is 7. Now you have your answer, right? So it is a classic binary search where you are doing multiplication. You are not using the classic SQRT method, which is provided in all libraries of all the languages. Without that, you can do integer square root. In fact, you can also do double. In fact, if you see the square root implementation, it is done using binary search only. The SQRT library is written using binary search. Okay. So find the square root of a number without using math library. And we will be coding this. Let me get the link of the problem. Yeah. So the problem is, just give me a minute. I'll just search SQRT code. And this is the problem. Okay, so how long was I on mute? Okay, you guys are able to hear me, right?
Yes.
Yeah. So now this is the same question. This is an easy question. Tagged easy in lead code. Now the same question, given a non-integer x, compute and return the square root of x. Since the return type is an integer, decimal digits are truncated, and only the integer part of the result is returned. You are not allowed to use any built-in exponential function or operator such as power or exponentiation. You can use multiplication. Okay, double star is used for exponentiation, for those who didn't know. Okay, so we will use the classic binary search. Code is already there, but let me rewrite this and I'll talk you through as I write it. Okay, so binary search for finding square root of x. Our search window will be 0 to x. In fact, not necessarily 0, but since the, okay, so the number can be 0, so we will do from 0 to x. Otherwise, I would have done from 1 to x, because the square root of 0 is 0. But now my search window will be from 0 to x, because x can be 0. Okay, so base condition, forget about it. Let's start from the middle. Int mid is equal to low plus high by 2. Okay. If array mid, so there is no array now. Okay, so mid times mid, like we did, if this number is greater than the number that you're searching for is x, then we will do something. If mid times mid is smaller than x, then we will do something. And if it is equal, then we will return mid as the answer. And we will handle base condition. So if my mid, right? So firstly, to make it easier for you guys to understand, I will make a variable long int guess. Why I'm taking long int? Because x ranges from 2 power 31. So 2 power 31 times 2 power 31 will go in range of 2 power 64, which is 64-bit number, and 64-bit fits long int. So long int guess is equal to mid times mid, right? So if you land in the middle, you multiply it. Like if I landed on 6, then I will check if 6 times 6 is greater or smaller than 49, right? So my guess is mid times mid, and now I'll replace for the sake of easiness. Now I'll be just using guess. So if the guess is greater than the number that we are searching for, which means like 12. So if I landed on 12, then what did I do? I started searching on the lower half. So x low mid minus 1. Okay. Similarly, if my guess was smaller, like 6, then I looked at the higher half. And if it is equal, then mid. Okay. So far, so good. Now let's come to our base condition. So how we will try to, so 49 had a perfect square root, which was 7. What if it is 48? You will never find a number whose square is equal to 48, right? But because this is integer square root, so square root of 8 will be 2. I hope this is clear. The square root of 9 is 3, but the square root of 8 will be 2. Actually, it will be 2.5 something, but because we are doing integer square root, so answer has to be 2. So now, every time it is not necessary that our guess will be equal to x. So now we have to rely on our base condition. So let's see how we figure out our base condition. And I will make you guys tell it what will be the base condition. So let's start off with a very simple example that I have guessed that you need to find the square root of 5. So we need to find the square root of 5, and I launched binary search 505. What is mid of 0 and 5? 2. 2 times 2 is 4. Is 4 greater than 5 or less than 5?
Less than.
It is less than 5. So your search window is mid plus 1 to high. So mid was 2. So now mid plus 1 is, mid plus 1 will be 3. Okay. And the last number, high is still 5. So now 535, this is your, these are the two numbers, which is low and high. Just making it, don't confuse. The first 5 is the number that you are actually searching for, making the square root for. So now your window is 3 to 5. 1 second. So your midpoint was 2. 2 times 2 is 4. 4 is less than 5.
5.
Then you start looking at the from mid plus 1 to high. So basically from 3 to 5. This sounds a little bit yeah. So yeah, right. That's how we will get to the base condition. Awesome. So now from 3 to 5 you will look. So 3 to 5, what is midpoint of 3 to 5? 3 plus 5 by 2, which is 4. Right. So now binary search 5. So I've taken this example because there is no number whose square is equal to 5. So now you will see how the base condition will help you arrive at the correct answer, which in this case is 2. But right now your window is outside 2. Sounds wrong, but you see how you will get the answer. So now your midpoint is 4. 4 times 4 is 16. 16 is greater than x. Now you look at a low to mid minus 1. Okay. So low is 3. Mid of 3 and 5 was 4. So mid minus 1 is 3. Correct? Any questions here? Right? So 3 to 3. Now 3 to 3, what is 3 times 3?
9.
9. 9 is greater than 5. Correct? So now your search window is low to mid minus 1. So now you will see how you will get your answer. Binary search 5. Low, which is still 3. What was mid? 3 and 3. Mid of 3 and 3 is 3. 3 plus 3 by 2, 3. And what will be mid minus 1?
2.
2. Right? So what should my base condition return? Firstly, my base condition has to be, it is always if low is greater than high. Then what should I return? High, low, or mid, or minus 1? What should I return? I need to return 2 here,
Low.
right? No, 2 is high. Answer for
Oh,
square root of
high,
5 is 2.
right.
So you will return high. Let's see if, so this is how this is how any coder gets a base condition. And now I will just take the name of God and run this code. And as usual, there is some runtime error, which is expected because it overflowed. So I need to make this long. And now, apparently, this is faster than 100% of C++. Okay, I'm surprised. Okay, cool. Any questions? So you just for you guys to know, give me a random number and I'll run this code and you'll get the square root. Okay. Expected output 28, output 28. Okay.
Yeah.
This is clear? Okay, awesome. Now let's move. So I will be coding this. I hope you guys can, I will be sharing this recording to all of you. In your spare time, you can also code. I have made the session in a way, I've set it up like a college professor. Everything is set. I'm just making some modifications in my code and submitting in front of you guys so that it is beneficial for everyone and I don't waste much of my time. Okay, so let's move forward. This is a small branding. Binary search problems. Now let's start. Now we covered 2 easy problems. Now this is our first medium level problem. What does medium level problem mean? Obviously, medium are harder than easy, and medium are the most asked interview question problems. That's also true. So now the question is, search for first and last occurrence of a number in a sorted sequence. Remember when I was talking about what are search problems? One of the search problems are find first and last occurrence of a number in a sequence. This question is find first and last occurrence of a number in a sorted sequence. Take 2 minutes to get that, and then we will start the solution. So imagine there is a sorted sequence with duplicate numbers 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5. And I ask, tell me the first and last occurrence of 5. This is the question. And this is a medium level question. Sounds like easy question. I will iterate through all the numbers. No, that's the order n solution. You start iterating through all the numbers, find the first and last occurrence. It's easy, but it is order of n. We need to solve it order of log of n. Okay, every binary search problem is solved in order of log of n. So it is quite simple, right? We already solved binary search in a sequence. And sequence is sequence. It can be duplicate. Numbers can be duplicated, maybe unique. So what's new in this? New in this is that if I search for 5 in a sorted sequence which has 5 multiple times, then I will get any occurrence of 5 and I'll return that yes, this number was there. Hard part here is that you need to find the first occurrence and the last occurrence. So one person can say, okay, we will do a trivial binary search. We will get any occurrence of 5 if there is 5. Any occurrence of 5 we will get, and then we will start decrementing the pointer from there to get to the first occurrence, and we will start incrementing the pointer from there to get the last occurrence. But then what will be the time complexity? Log of n to find first any occurrence, and then iterating, going one step back to the first occurrence or one step forward to the last occurrence. This will take order of n time. Why this will take order of n time? Because assume there are only 5s in the array. So you get to any number, any index in the array, and then you iterate to all the way to the front of the array and iterate to all the way to the last point of the array. And then you tell me the first and last position. You actually traverse the entire array, which is order of n. Is this clear to everyone? That why trivial binary search won't solve the first and last occurrence question? Any questions? Are you able to understand the question? Any questions on the question?
No.
Okay, awesome. So you guys understood the problem statement. As usual, I'll be going ahead and submitting. So this looks like this is actually the answer for this code. And this looks a little extensive. You will think that this is huge. It's not that huge. In fact, we are going to submit this. Okay. Firstly, let's finalize the algorithm. So we will take this question. And target, we will keep the same. Target is 8. So first occurrence of 8 is at index number 3. Last occurrence is at index number 4. Expected output is 3, 4. Let's see how we will do it. So a trivial binary search won't work here. Okay. So in a trivial binary search, whenever you get 8, you return 8. Now I'm saying that here you need to change. Here you have to do that whenever you get 8, you don't return there. You keep looking, if you are solving for first occurrence, keep looking at the lower half. Okay. Let's try it out. So this is 0, 1, 2, 3, 4, 5. So low is 0, high is 5, and mid will be 2. So you go to the second index of this array and you check if it is equal to 8, greater than 8, or less than 8. It is less than 8. So you'll go at the higher part. Higher part is mid plus 1, which is now low becomes 3 and high remains 5. And now the mid becomes 3 plus 5 by 2, which is equal to 4. So now mid is at the fourth index. Which number is at the fourth index? 8. You don't return here. Okay. When you get equality, at equality, do like you were doing as if the number is greater than it. Okay. Still look at the lower half. So again, I will look at the lower half, which is low to mid minus 1. And high will be equal to mid minus 1, 4 minus 1, which is 3. And mid also is now 3. And now at this element, we are seeing 8 is equal to 8. But again, as I said, we will not stop here. What if this is also 8? We don't know. This can be also 8. So again, we will go to low to mid minus 1. So low equal to 3. High equal to mid minus 1, which is 2. And now mid is not necessary. Why? Because now low has become greater than high. As I have already said, this is a base condition. So when low is greater than high, then which index should I return? Which index should I return here? I should return, the correct answer here is 0, 1, 2, 3, right? I should return low. So I can, so this is roughly, I'm letting you guys know that this is how we will solve. So either I can return here. If low equal to high, we can return here. Or when low greater than equal to high, then we can return with low. So both places are correct return points. Okay, so what we did, that we did not stop at equality. At equality also we kept going to the lower half and we got the first occurrence. For the last occurrence at equality, still you will keep going at the lower half and you will get the last occurrence. Intuitively, are you guys able to understand this much? How I am able to get to the first and last position using by manipulating binary search a little bit. Is this clear?
Yeah.
Clear, right? So like I started with 0 to 5, mid was 2, which was 7. 7 is less than 8. So I went to the higher sequence. Mid is 4. Now mid 4 is actually this 8. Now this 8 is equal to 8, but at equality also I've decided I'll go to the lower half. So now 3 to mid minus 1, which is 3 to 3. And 3 to 3 here, either we can return 3. This is also a valid return point, or we still go further down and we will decide. I'm yet to decide what algorithm I want to use. So now low is equal to 3, and next time high becomes mid minus 1, which is 2, and the recursion stops here. So I can return either here or here. So both are correct. So now I will implement the first occurrence. Well, let me quickly implement the first occurrence. And while I'm writing code, feel free to ask me any questions. Low greater than high, then I'll do something. What I'm thinking that for a change, I will actually return when low equal to high, like here. At low equal to high, I will return. If nums low target, then I will return. Okay. And here I will return -1. Because remember, if it is not found, I have to return -1. So I have to distinguish between not found and first occurrence. So this is how I will distinguish. And rest all is pretty vanilla from here. I will be just doing the plain old stuff. Mud equal to target. You need to tell me what I need to write here. For greater, I'll write nums mid is greater than target. Return first occurrence nums target low mid -1. Else, which is the smaller case, then I will return first occurrence nums target mid +1 high. Okay. Anybody can tell what will go here? If it is equal, then which half do we go? Lower half or higher half? We just discussed that. For first occurrence, where should I go? Anyone?
Lower half.
Lower half.
Awesome. As suggested. Should I go mid -1 or mid? This is the tricky point here. I will go to mid, right? Because so here, if it is greater, mid I can reject. Mid is not the answer. So I always go to mid -1. If it is smaller, then I reject mid and I go from mid +1 to high. But here it is equal, but I don't know whether this is the first occurrence or not. So I will keep it inclusive, low to mid, not mid -1. That's the only correction which I will make here. Okay, and that's it. So this is my first occurrence, still a 5-liner. And I will copy paste this. For last occurrence, what changes I will make? At equality, what will happen? Anyone?
We'll return the high.
Higher half. We'll go to the higher half. So firstly, so when it is greater than target low mid -1, this is correct. This is correct. Then here I need to do mid high. Again, I'll keep mid inclusive. And here is small. Yeah, this should work here. We will make this correction. I'll tell why I'm making this correction. But every time you solve last occurrence, you have to modify your mid to low plus high +1. And I'll tell you why. I'll add a comment here. And while this, I think, remains same because, yeah, this sounds about right to me. Let's submit this. Okay, I still need to write the main method. So main may have to return a vector. So I'll return a vector. Vec dot push back. So I will, what do I need to push back? First occurrence and last occurrence. First occurrence nums target 0 nums dot size -1 and then last occurrence and return back. Okay, let's see how many compile errors are there. I'm quite surprised at this. Okay. I hope this submits. Awesome. So we just solved this problem as well. Okay. Why did I do this? Now, consider this. This is the tricky part. Okay. This is the part where wrong answers come. So let's say you have a 2-element array and low is 0 and high is 1. So when low is 0, high is 1, and let's say this is 4, you want to return the higher, you want to return the index number 1, not index number 0. But every time you do mid, low plus high by 2, what will you get? You will get 1 or 0. 0 plus 1 by 2 is what?
0.
0. It will always be 0. 0 plus 1 by 2 will always be 0. And at equality, you will restrict to mid to high. Mid to high क्या हो जाएगा फिर से? Mid to high will be again 0 to 1. मतलब low again becomes equal to 0 and high again becomes equal to 1. Again, what mid will come as?
0.
Infinitely this will occur. And this will call TLE. And I will actually go ahead and make this an timeout and let you guys know. Timed out as expected. So why did I make this offset? I made this offset so that when there is a condition like this, then you modify your mid algorithm. If low is equal to 0 and high is equal to 1, then now your mid is 0 plus 1 by 2. Now what is mid? Is 1. Okay. 4, 4. So at mid it is equal. So I go to 1, 1. So now my low is 1, high is 1, and mid is also 1. And when low is equal to high and it is equal to target, then I have my base condition written here. So I will return. This is my exit point. Is this part clear? Why this is timing out and why adding +1 here is working?
Yeah.
These are some small nitty-gritties that you should know. Otherwise, you will keep endlessly debugging your code. And these are very hard bugs to fix. Okay. Again, submitted it. And it is faster than around 71% of C++ submissions. I'm quite happy with this. Okay. Okay, now comes to the most tricky part of this session. Can binary search be applied in unsorted sequences as well? So far, we only did it on sorted sequence. Can we do it on unsorted sequence? That's the question. So answer is, it may be unsorted, as in it may be applied on an unsorted sequence, but there needs to be some pattern of arrangement. So sorted sequence is nothing but a pattern. Okay, pattern is key. It is ascending order. AI is always smaller than AI plus 1, smaller than or equal to AI plus 1. Any such pattern, like it increases and then decreases, which is called a peaking sequence or a mountain array, or it can be a sequence of peaking sequence, or it can be a decreasing and then increasing sequence, which is called a monotonic sequence. Any type of pattern that is there in a sequence of number, you have a scope to apply binary search. Any type of sequence, any type of pattern, if you can spot in a sequence, you may have a chance to apply binary search, and we will do one such problem, which is again a leet code medium, which is find a peak in a unsorted array. And this is a great question. I highly recommend this question to everyone. And this is a mountain sequence. So an array ARR, a mountain, has following properties. To save you the difficult maths, it is basically a mountain. Construct a mountain, firstly increases and then decreases. So 0, 1, 0 increases till 1 and then decreases. 0 to 1, 0, 0 to 2 it increases, and then from 2 onwards it decreases. 0, 10, 5, 2, 0 to 10 it increases, and then from 10 onwards it decreases. So you need to find the peak, which is 10 in this case, which is 2 in this case, and 1 in this case. You need to return the index of that number. Remember, it has to be strictly mountain, which means it has to increase, monotonically increase, and then monotonically decrease. You can't have a sequence like this. Firstly, you increased, and then when time came to decrease, then you had a 7 here. So this is not a valid input. Okay. This is not a valid input. A valid input would only be this. It has to increase and then decrease. Any questions on the question? Is the question clear?
Yeah, I have a question here. So
Yes.
let's say invalid input is given. Right? So that is not possible, right? Invalid input
In this case, in leet code, it's not possible because they have already told that. But yes, let's say invalid input is given.
But in case of valid input, won't it be the case of the highest number?
It will be the highest number. But how will you find highest number in a sequence? Order of, say it, order of,
Sequentially order of n, otherwise we
order
can
of n,
divide
order
it.
of n over. Order of n, matlab order of n, mein everything can be done.
Right.
You have to do in order of log n,
Hmm.
right? That's the question. Any other doubts?
No.
Okay, awesome. How will we solve this? This is very simple. I'll not rewrite the whole code. It is quite simple. The idea here is that you will start from low, which is the first element, and your high will be at the last element. Your mid can be anywhere. Okay, yahan pe blah 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 can be there. You just know somewhere it has peaked and then it has decreased. You only know this. So now that somewhere, let it be anywhere. Okay, you need to find whether your mid पे uphill है या downhill है. If your mid is at uphill, मतलब peak is yet to come or has passed. If you are going uphill, then peak is yet to come or it has passed.
Yet to come.
Yet to come. So your search sequence will be mid to high or low to mid?
Too high.
Mid to high. And if your mid is at downhill, if somehow, some magical power, you are able to detect that your mid is downhill, then your peak will be from low to mid or mid to high?
Low to mid.
Low to mid. So binary search lag gaya. And that's what I did here. Int low -1. This is classic. No explanation required. Mid is equal to low plus high by 2. And this is how I'm detecting. But this is the peak. This is the criteria for peak. What is criteria for peak? Ki the number immediately behind it and the number immediately forward of it, both have to be smaller than mid. Correct? मतलब 1 है तो उसके just पहले 0 है and just after 0 है. 1 is greater than the number before it and also greater than the number after it. That's the definition of peak. है ना? So that's what I've written. Array mid has to be greater than mid -1. Array mid has to be greater than mid +1. If you find such a mid, then that's the peak. Congratulations. But if you don't find, then what do? Then you find whether it is uphill. How do you know if it is uphill? How do you know if it is uphill? If mid +1 is higher than mid, which is the else of this, then you will go to the lower half. Matlab mid +1 say high, like you have already told. And if it is downhill, which is mid is greater than mid +1, then you will search in the lower half, low to mid -1. And that's it. Same code. It is exactly same code. Only your equality condition has changed. And your greater and smaller condition has changed. And if I will submit it, it will get accepted. No surprises there. But yeah, any questions, any doubts here? Why binary search worked here? Because every time you land on mid, you have to just ask this question, whether this is peak. If it is peak, then you have your answer. If it is not peak, then you need to find whether you are going uphill or whether you are going downhill. If you are going uphill, तो अभी peak आने वाला है, right? Peak is yet to come, so low to, so you will go mid +1 to high. If uphill, and if downhill, then peak has already passed. Go back, low to mid -1. Any questions? Any doubts?
What if we have a multiple peaks, like we have multiple mountains, like 2 or 3 mountain? Can we implement binary search on it?
That's a great question. That's a absolutely great question. And why that's a great question is because of this. This was my next question. So now it is what you have asked. So here there are multiple mountains and you need to find any of the peaks. And still we can apply binary search here, but I will not come to that. But your question is duly noted and I will be covering in the next question. But any other questions apart from that? Any other questions? Any doubts? I hope this is clear. Yes or no, guys, anything would work. If not, I'll explain it again. Next question is strongly correlated. Okay, thank you. I'll take that as a yes. And let's move to the next question. Next question is that you need to find a peak element, and peak element is an element which is strictly greater than its neighbor. Same thing. But this time there is a plot twist. And the twist is that given a 0 index integer array nums, find the peak element and return its index. If the array contains multiple peaks, return any of its peaks, right? For one peak we have already solved. Now here the question is that it can have multiple peaks. This is given, that you have a sequence which will have multiple peaks and you have to return any of its peak. And you can imagine that the like element before the first number and element after the first number is minus infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside there. Okay, and you have to solve this in order of n. So isme what you will do? Can anybody now tell how you will apply binary search? How will you apply binary search now? Just think through it. Can I use the same algorithm? Can I use the same algorithm? 1, 2, 3, 4, 5, dot, 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 dot. I don't know what is happening here, but I know that it will come. This also I don't know actually. Okay, it's all actually blah, 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 blah. Here. So this is our A1, A2s. I just know that these are a combination of peaking sequences. And you have n. So I'll give an intuition and then you guys yourself will answer. So you will have 2 pointers as usual, one at low and one at high, and you will land at any mid. Okay. If that mid is the peak, which means mid is greater than mid plus 1 and mid is greater than mid minus 1, elemental mid minus 1 and elemental mid plus 1, then you have the peak, you return the answer. That's the lucky case, but that won't happen always. So what's the other cases possible? Now, imagine I use the same algorithm, exact same algorithm. If the peak is there, I'll return mid. If the peak is not there, then I will see whether it is uphill or downhill. If I encounter that my mid is uphill and I don't know what peak is peak ka uphill, I don't know. Forget about it. I know that my mid is somewhere uphill, but I definitely know that my high, which is the last pointer, is always at a downhill. This I always know. Why I always know? Because it is bounded by minus infinity. So ये हमेशा downhill होगा. Here is minus INF and here is also minus INF. This is provided by the question. So this will always be uphill and the last number will always be downhill. Okay? Okay. So now if my mid is uphill, of what peak I don't know, and my high is downhill, of what peak I don't know. But can I tell that there will be at least one peak in between uphill and downhill? Yes or no?
It could be.
It has to be. If I am uphill, mid is uphill, and my high is downhill, there has to be at least one peak in between them, right? There can be multiple, but there has to be at least one. अरे मतलब uphill है तो peak तो will come ना? Otherwise, how it will be uphill? Correct or not?
Yeah.
Is this part clear? Yes, awesome. तो वही फंडा है, same thing again. So if it is uphill, I go later half, downhill, I go higher half. मतलब downhill I go first half, uphill I go later half. Same thing. Intuition here is, if you are at any uphill slope and your last pointer is the last element of the array, then you know for sure that there has to be a peak, because if you are going uphill, a peak has to come. At least one peak will come, right? If nothing, an will be a peak, right? Why will an be a peak? Because an will be always greater than minus infinity and an minus 1. Maybe an minus 1 is smaller than. So at least one peak will be there between mid to high. Correct? Imagine you are driving. There are two drivers. One is going uphill and one is going downhill. Can the both driver definitively say that between them there is a peak? They are on the same route. They are not on different geographies. So let's say you are traveling on a road, and on the same road, you are going uphill, and one person is saying that I am going downhill. By just this statement, can you tell that if the person going downhill is ahead of you, then there is at least one peak between you who is going uphill and the other one who is going downhill? Yes or no? Imagine. If you are going uphill and a person ahead of you is going downhill, then there has to be a peak in between you both.
Yeah.
Yep. So that's the logic. And these are just some base conditions that you need to take into account, because mid minus 1 should not be negative index, right? So due care has been taken for that. And you can go through this. This is just same. If you focus on this part, then they are exactly same. This is for uphill. This is for downhill. This is for peak. This is for downhill. And this is for uphill. And then return -1, because I have written all three conditions here. This will never be encountered, but I can't write a method whose all branches are not returning something. So I'm just returning -1. If not there, this will be what will be returned. And if I submit, this will be accepted. Okay. Intuitively, you guys are able to understand, I hope. I hope you guys are able to understand this. Yes?
Yeah.
Okay. Okay, that's another branding. And then now we have come to the moment. Now we are going to do hard binary search problems. And I will need some pen and paper to explain, which I will do. But yeah, the question is, this is a really hard problem, guys. You need to find median of two sorted arrays. This is a question of just 6 words, find median of two sorted arrays. This is one of the most complicated problems that you can encounter in a interview. God forbid it comes. But just see, this is the code. I will not explain, even try to explain my code. I'll explain the logic, but this is very complicated. Okay. I'll start with pen and paper mode of explanation now. And just give me a moment. Are you guys able to see my screen?
No, it's coming blank.
Not yet, yeah.
Okay, just a minute. Let's try again. Are you guys able to see my screen now?
Yes, there's a black.
Yeah, that is my pen and paper for today. Okay, so let's start. So you need to Is everyone able to hear me and see what I'm writing?
Yes, yes.
Can I get a thumbs up? Okay, thank you. Okay, so what this question is? So you have two arrays. ठीक है? So another array. This is also sorted. This is a very tough question, guys. Okay. And I hope I'm able to explain it to you guys. Even the easiest solution of this problem is very hard to comprehend. So the only way to explain this using a pen and paper. So don't mind my bad handwriting and let me start. So what is median in a sorted array? What is median in a sorted array? Anybody can answer this question? Median in a, what is median? Matlab, simple question. All of you know, I'll just revise it. So if you have a sequence which is sorted, then median is the middle point of that sorted sequence. What will be median in this case? In this case, median was 2. What will be median in this case? Can anybody answer? What is middle point of this sequence?
2 plus 2 by 2.
Exactly. So you will take both the numbers in the middle, plus them, and divided by 2. Another example. What is median of this array? What is median of this array?
4/2, which is 3.
So how many? Firstly, we will find a mathematical way. 1, 2, 3, 4, 5, 6, 7, 8. If they are even number of elements, then there will be not exactly one element which will be at the middle. There will be two elements which will be at the middle, and which will be index number. You'll firstly find index number pe agar aana hai. So this is from 0 to 7. So you will not use 8 if you need to find a 0 index. So you will do 7 by 2. 7 by 2 is what? 3. So 0, 1, 2, 3. So 3 and 3 plus 1. Both you will take. This both average of this 3 plus 4 by 2 will be median of this. In this case, how many numbers are there? 1, 2, 3, 4, 5, 6, and 7. 7 numbers are there. So if there are odd number, then there is exactly one number which will be at the middle, and that number will be at 7 by 2th index, which is 0, 1, 2, 3. This index. Yahan pe bhi 3, yahan pe bhi 3. So this is your median. And 3.5 is your median here. Any questions, any doubts? Before we move ahead, this is definition of median. Is this clear?
Yeah.
Okay. Feel free to prompt me, guys. This is probably one of the last questions that we'll be doing in the session. So I am happy to go in any level of detail. Okay, so now you know what is median. So we have covered what is median. Now let's come back to our question. Median of two sorted array. Before this, answer me what is median of one sorted array. You know what a median is. If I give you a sorted sequence, what is the median of this single sorted array? If it is odd, then this is the element at let us do it A0 to n minus 1. This becomes, and if it is even, then is this clear? Median of single sorted array. This part is clear.
Yes.
Odd length, even length. What is time complexity of this?
And log n?
Okay. What is time complexity of this? How will it? So this is a formula, right? Odd. If it is odd, then median is n minus 1 by 2th element. If it is even, then it is n minus 1 by 2th element plus n plus 1 by 2th element ka average. So what is the time complexity to compute this?
1.
Order of 1. Yes. O of 1. ठीक है? यहाँ तक any doubt? We need to solve this problem in order of log of n. ठीक है? Now let's come. Now let's start. Okay, let's start. So the way we will solve this is, so firstly, what does median of two sorted array mean? Okay, first let's understand the question. If you have array 1, 5, if you have array 2, which is 2, 4, 6, then Median of two sorted arrays का मतलब ये है कि if these two sorted arrays were concatenated, then what would be the median? So if you concatenate these two arrays, then what sequence will you get in sorted fashion?
1, 3, 1, 2, 3.
In sorted fashion, you will get 1, 2, 3, 4, 5, 6. What is median of 1, 2, 3, 4, 5, 6? Come on, use the formula and answer. What is the median? 3 plus 4 by 2, which is 3.5. So this is the question, that given two sorted arrays, you need to return me 3.5. But if I concatenate two sorted arrays, how much time will I take to concatenate it? If I need to append two arrays, कितना time लगेगा append करने में? Anyone?
And
Order of n. And how much time will I take to again sort it? This I will answer, order of n log n. And then in order of one time you will get. So the solution turns out to be order of n log n. You can improve it a little bit by using some algorithm, which I'll not get into. But the best you can do is order of n. But question demand is कि solve it in order of log n. ठीक है, order of n तक you can solve it without binary search. Okay.
What we can use for order of n if we are not going for binary search?
You can use the very famous algorithm for merging two sorted arrays. You can have two pointers. If the one which is smaller between 1 and 2? 1. So you'll put 1 and you'll increment the pointer. Now, which is smaller between 2 and 3? Which is smaller between 2 and 3? Increment the pointer. Now, which is smaller between the two pointers?
3.
Increment the pointer. Which is smaller between the two pointers now? Increment the pointer. Which is smaller between now you have sorted it in order of n time. Sorted and concatenated in order of n time. Now in order of one time, you will get the median 3.5, but you took order of n time, which is not correct. As in, this is correct, but you will fail the interview because you are expected to solve this in order of log n. Till this, is it clear?
Yes.
Yeah.
So now, median of two sorted arrays. How will we solve this in order of log of n? And now this is a simply beautiful, there is a very good explanation for this. How you can use binary search to solve this. I'll take the typical example. So the answer is quite non-intuitive, and it uses that if, let's say, you find the median number, then how many elements will be on left of it and how many elements will be on right of it? Number of elements. They will always be equal, yes or no?
It depends on
Yes.
odd or even, right?
Why? If it is
it will
even,
always remain equal,
yeah, it will always
even if
remain
it is
equal.
even or odd.
Yeah.
Yeah.
Even if it is even, then you'll have two numbers in median, and for both two numbers, the numbers in left and in right will be equal.
Okay, okay.
Right? In this case, you can take an example. Okay. Which means left and right are same, plus the number of medians, which can be 1 or 2, will be equal to n, right? So if there are n elements here and m elements here, and now for odd case, for even case. So odd case, how many elements will be there? We will only talk how many elements will be there on left of it. If that is x, then right of it will be also x. So only we will consider how many elements will be on left of it. How many elements will be on left of the median number if this is if n, odd kya hai? N plus m is the new sequence, right? If n plus m is odd, then how many numbers will be there on the left of the median? Okay, when you will concatenate both the array and write a sequence and find a median, then how many numbers will be on left of the median? That's the question. So there will be 8 elements in total. Median will be at the 4th index. 3 elements. Sorry, this is even
It's an
case.
even.
Even case. So 2 elements will be in median. So basically 0 to 7, 8 elements are there. 7 by 2 is 3, 7 plus 1 by 2 is 4. So index number 3 and 4 will be your median, and there will be 3 elements on both part. So the formula which comes out is
Minus.
for even, and let's see what it is for odd. So if this was an odd sequence, then also it turns out that this is 3 and 3. 1 second. Let's do this properly. So if this is odd, then what will happen? Take an example, 0, 1. So the median is 2. How many elements are here? 2 and 2. So n plus m is 5 here. And there are 2 numbers here. So n plus m by 2. So if it is even, then n plus m by 2 numbers will be on the left of it. And if it is odd, sorry, exchange it. If it is even and odd. So if it is odd, then n plus m by 2 numbers, even. We'll validate with some examples. Okay, so if n plus m is even, which is this case, the concatenation is 1, 2, 3, 4, 5, 6, 7, 8. The median is 4 and 5. And here are 3 and 3. So n is 4, m is 4. So n plus m by 2 minus 1, which is 3. Correct answer. If I remove one number from here, then my concatenated sequence becomes 1, 2, 3, 4, 5, 6, and 7. And my median is 4. How many numbers are on left of it? Which is 3, which is n plus m by 2. Okay, so m for odd and m plus m by 2 minus 1 for even. Okay, point is that in order of one time, you can find out that number of elements on its left will be either be n plus m by 2 or n plus m by 2 minus 1. Till here, any doubt, any question?
No.
No. Now you will be able to apply binary search. Now the pieces will stick together and you will see how we can apply binary search. And now it will take just 5 minutes from here. So now what you will do is you will do binary search on array 1. You will forget about array 2. Okay? Take it on the face of it and you'll understand the logic. You'll only apply binary search on array 1. So array 1 pe low pe fix kar diya one pointer I fixed on high, and now mid comes out to be, what is mid? 0 plus 3 by 2, mid is 1. So we say that we will partition this array at 1 index. Don't understand partition? Okay, forget about it. It's okay, you don't know. So we will partition this array at index number 1. If now I will explain what partition means. So basically, okay, forget about this. Let's go one more step back. So now we know that n plus m by 2 elements before in case of odd and n plus m by 2 minus in case of even. And now what we are actually trying to do is that we are trying to partition this array in a way. We are trying to create a partition here. Let's say in this case, we create a partition here. So what does this mean? That this half and this half, if they are correctly partitioned, which means that this 4 and this 5, this 4 is less than this 5 and this 3 is less than this 6, then what does this mean? That you have divided both the arrays into two halves such that the lower half is together and the higher half is together. This part is clear. Don't ask me how we will partition. I'll come to that. If you are able to partition, if you have a magical function which partitions it in a way that half numbers are here and half numbers are here, then you will end up like this. And now your median will be what? Highest number in your lower half and highest number in your higher half plus by 2. Okay? Which is 4.5 here. Is this part clear? Let's take another example. This is the main concept. It may be a little hard to understand. Let's take this example. Array 1, array 2. I am asking that if I am able to, if I have a magical function which partitions this like this, don't ask me how. I will explain that how. If I'm able to partition this like this, and such that I end up with equal number of numbers on the left part and equal number of numbers on the right part, right? Then if I take min of this and max of this, and then by 2, I will get the median. Is this a statement true? If I am able to partition this correctly, then yes, of course, this is true. Max of this is 3, min of this is 4, 3 plus 4 by 2 is 3.5, which is the median. So now the problem is, how can I create a partition such that equal number of elements are on the left part and right part, and they follow the sorted principle? What is sorted principle? That because this array is sorted, so 3 will always be less than 5 and 2 will be always less than 4. This 3 should be smaller than this 4. And so basically, in this sequence, when we have partitioned it like this, you are saying, your claim is that all elements on the left part of this partition are smaller. So what literally, there is only 2 comparisons that you will do here. This is hard, I know, but bear with me. So this 3 should be less than this 4, and this 2 should be less than this 5. Only if you are able to make these 2 cross checks, and if they are true, then it will mean that you have created a partition such that all the elements on the left of this partition are smaller than all the elements to the right of this partition. Because 3 will be always less than 5, 2 will be always less than 4, and this partition may only cross comparison we can do. So we compare 3 with this 4 and 2 with this 5. So on the boundary, we compare the zigzag elements. And if they follow the property that elements on the left partition are always smaller than the elements on the right partition, then we have successfully created a partition so that equal number of the elements are there on left and equal number of elements are there on right. And then finding median is easy. Is this much clear? How to create partition, I'll come to it. But is this much clear?
Yes. And does it make any problem if there are any duplicates in the sequence?
No, it doesn't. It doesn't really. It won't make a problem. Good question, but okay. So now the question is, and I will generalize now. Okay. So now I want to create a partition which is equal. So agar n plus m elements are there, so where should I place my partition such that equal number of elements are here and here? I'll place the partition at n plus m by 2. Tabhi to n plus m by 2 elements will be here. So you will do binary search on the first array. Now coming back to what I was saying, you will do binary search on the first array. 0, n minus 1, land on mid somewhere, ak, and create a partition here. So 0 se k, how many elements will be there? You know this. 0 se k mein kitne elements hai? K plus 1 elements. How many elements should be there overall in the partition? Overall in these two partitions, how many elements should be there?
N plus m by 2.
If I remove k plus 1 from this, will I automatically get a partition on the array 2? Correct or not is what we have to validate. But if I place a partition at k, then automatically the partition will be at this index in array 2. Is this statement clear? at thisth index, you have to place the partitions such that n plus m by 2 elements are there in the left partition and right partition. This is clear, right?
Correct.
Right. Now only you need to validate. Let's say this is L. So BL, यहाँ पे BL plus 1 है, और यहाँ पे AK plus 1. Now you only need to validate that AK has to be less than BL plus 1 and AK plus 1 has to be greater than BL. Okay. If these both hold true, then you have got your successful partition. And now only you need to take max of this and min of this, and you will min of this and that meaning. AK and BL ka you will take. AK and BL are the only two contenders, and AK plus 1 and BL plus 1 are only two contenders. So you will take max of this and min of this and plus them and by 2 if they are even. If they are odd, then just you will have just one number, right? If it is odd, then we will talk about that separately. Firstly, let's solve for even. So you will take max of this, min of this, and plus 1, plus them and by 2, and you will get your answer. Why you get your answer? Because you have successfully created a partition such that the numbers on the left of it is always strictly smaller than the numbers on right of it, which is the definition of median. Median is the rank has to be in the middle. I may not have achieved the sorted sequence, okay, but I have achieved a partition which divides the array into two halves of equal parts, and the partition is placed such that the left half is strictly less than the right half, and now the boundary elements will give me the median, because the boundary elements pe to median hoga na. Like if you create a partition in the middle of the array, then median will be at the either two boundaries, or the line will exactly pass through the median. Are you guys able to understand this? This is the only point where little bit difficulty is there to understand, but I'm happy to help you guys. So if you place a partition at any index, अब इसको simpler terms में I will explain. Maybe this will be easier for you to understand. That if I place a partition without using mathematics, if I place a partition, let's use numbers 1, 3, 7, 8, 9, 11, 2, 3, 4, 5, 6, 7. And if I place a partition at 7, let's say, and I know that there are 6 numbers here and 6 numbers here, 6 plus 6 by 2 is 6. So if I place the partition at 3, I have to place partition at 3 here, so that I have 6 elements here and 6 elements here. Now I need to see that my 6 elements here are strictly smaller than the 6 elements here. These 3 numbers I know are smaller than these 3 numbers because they are part of sorted array. These 3 numbers are smaller than these 3 numbers because they are part of the same sorted array. I just need to cross compare them. So I will compare 7 and 5. Turns out 7 is greater than 5. So this is not a successful partition, right? Because it has 3, 7, 2, 3, 4 here, and it has 8, 9, 11, 5, 6, and 7 here. It has 7 and this has 5. So you have not partitioned it correctly. So this partition won't work. So now our binary search will either go to the left half or the right half. So now we will either go to the left half or the right half. Okay. So if you are not able to successfully create partition at 7, because your 7 was greater than this 5, which means I have to go less. So I go less here. If I place a partition 1 less here, so my partition in array 2 will move 1 place up. If I have to keep n by 2 elements, if I have reduced it here, then I have to increase this here. Is this point clear?
Yeah.
Yeah.
Right. So now ab compare karna hai ki is this a proper partition? Now you compare this 3 with this 6, is small hai. You compare this 5 with this 7, again is small hai. Matlab ki this is the correct partition. So now you have partitioned it to 1, 3, 2, 3, 4, 5, and you have partitioned here 7, 8, 9, 11, 5, 6, 7. And you can see all elements here are strictly less than all elements here, which means that now your median is the boundary numbers, one of these boundary numbers. And what formula I said was max of this 3 and 5 ka max le lo 5, 6 or 7 ka min le lo 6 by 2, which is 5.5. And that's the answer. You can see if you combine these two sequence, you will get 5.5, 1, 3, 7, 8, 9, 11, 2, 3, 4, 5, 5, 6, 7. If you combine them, then your answer will be 5 plus 6 by 2. Thoda, are you guys understanding?
Yeah, one question. If suppose we get a equal number, right? 3, 3 or something, like we have like all 3 here and all 3 here.
Let's say all 3 here. This is a valid partition. Why this will be a valid partition? Because this will be less than or equal to. Matlab, understand this, that this will only be not a valid partition if any one number here is greater than any number here. Then we will say that you partitioned it in a way that your one of your elements in left part is greater than any element in the right part, which means that you have broken it down into 2 halves of n by 2 each, but your median will not lie on this boundary because you have your sorting criteria will not be fulfilled because you have a high element on the left half. समझ में आ रहा है ये? You are able to understand the nuance here? Yeah, that's the small point here. So, in interest of time, just simply put, we will have a sequence of numbers. We will have a sequence of numbers here without much. You will place a partition here, and depending on what numbers are here, you will immediately get how many numbers have to be here, because you know that total number of elements on the left half is equal to total number of elements on the right half, which is equal to n plus m by 2. And you know where you have placed the partition on the first half, so you'll get here. Let this be AK, let this be AK plus 1, let this be BL, let this be BL plus 1. And now you just need to validate that AK is less than BL plus 1 and BL is less than AK plus 1. Kyunki AK is always less than AK plus 1 because it is given that this array is sorted. BL will be always less than BL plus 1 because it is given that this array is also sorted. So only you need to compare these two things. And once this is true, now your answer is one of these 4 elements. And you will take max of this, min of this, plus them by 2, and you have your answer. Where is binary search coming in? Binary search is coming in placing this partition. So I don't place the, I don't place the partition once here, once here, once here, once here, once here, once here. I place the partition in mid. I get the partition here. If it fails, then I will see AK was smaller or greater, and depending on that, I will go on the left half or on the right half. Okay? Now let's come to the code. I will just show you the code which I have accepted. This is the code. It will look a little more better. So this is doing find partition, which is what I was explaining, and this is the runner method, basically. So the runner method it's a little complicated, but yeah. Let me see. Simpler method which I have, yeah, this should be a little bit simpler to you guys. So find median, you can see that I'm doing the same thing. This is where the magic is happening. So if I'm able to find, this is where I'm cross-checking. If nums1 mid1 is less than nums2 mid2 plus 1, this is the cross-checking. If this holds, then I have my median. I just compute my median. If this doesn't hold, then I go to the left half or I go to the right half. Okay, this you can think a little bit more while you have free time. This is a little hard to understand, but if you can check, like I was showing in the diagram, depending on where you have placed the partition on array 1, you can figure out whether you have to go to the left or whether you have to go to the right. And a bunch of, okay, sorry for the expletives, but I had to submit this multiple times to get a correct answer. But yeah, see, I finally got it accepted. So there are a lot of corner cases here. So you guys are able to see my screen, right? My lead code screen. Yeah.
Yes.
So yeah, it took me a lot of time to bypass all the corner cases. There are a bunch of cases like there is one array is empty array, one array has just one element, and it fills all the corner cases. And that's what it makes this problem tough. But at the end, we can solve this using binary search. So that's all from my side for today. I had one more problem, which was, I'll not discuss that problem. I'll just tell what I didn't cover, which was split array largest sum again. Smallest question is the hardest one to implement. So this is a forward question, but again, this is very hard to implement. We don't have enough time today. So we will maybe take this up problem in the next class. Today we did 6 or 7 problems, and I hope you guys were able to understand all of them, and this was productive to you guys. So that's all from my side. If you don't have any questions, I'll end it right now. Any questions?
I have one question. I mean, so
Yes.
in the median of 2 sorted arrays, right? So until taking the partition, it's fine. There was one last thing that you had told about finding the median. If you could go back to the example that you were projecting on
Yeah.
the blackboard.
Sure. 1 minute. Let me project that again. Let me know if you guys are able to see my screen. It will
Yeah,
take a
now-
little. Yeah.
Yeah. Now here I had gotten it until the partition, right? Like checking if the partition is rightly like done. Now finding the median. Can you please explain the last bit of
Achha,
finding?
median, how do if you
Yeah.
have found the partition correctly, now it's a simple problem. So write all the elements on the left part and all the elements in the right part. Okay?
Right.
So now you have to get max of this and min of this. Now this can be simplified. How this can be simplified? What is max of this? AK.
Right.
What is max of this? BL.
BL.
So what will be max of these both combined? Max of AK and BL?
And yeah.
Either of these two, max of this. And what will be min of this whole? Min of?
AK plus 1 and BL plus 1.
Yes. So you will take this if this is even by 2 and you have your median. If this is odd, formula will change a bit, but nothing else changes. Okay.
Yeah, perfect. Yeah. Thank you.
Awesome. Okay, as I was. Any questions, guys? Any doubts, any questions?